T minus 4 seconds. 33 engines about to ignite simultaneously. This is the highest chamber pressure SpaceX has ever attempted. The engineer's heart rate is spiking. And they're about to learn if version 3 can handle what's coming. This will be the highest chamber pressure we've ever seen on a vehicle at SpaceX. So definitely going to be a pretty spicy test today. That's how SpaceX engineers describe what they're about to attempt with Booster 19, a test so intense that even seasoned rocket scientists admit their heart rates spike when. The countdown hits T minus 40 seconds. T minus 4 on is when my heart rate really starts to tick up. The question they're asking isn't whether 10 engines can fire together. They've done that before. The question is whether 33 Raptor 3 engines, each generating more thrust and running hotter than any previous design, can ignite as one unified system without tearing the rocket apart from the inside. And if something goes wrong at this scale, the consequences aren't just expensive, they're catastrophic. Why version 3 exists? SpaceX didn't build version 3 because version 2 worked fine. They built it because getting humans to Mars requires capabilities that don't exist yet, and incremental improvements weren't going to cut it anymore. Starship is a fully reusable two-stage rocket system. The booster accelerates the upper stage, called ship, toward orbit, then returns to Earth to be caught by mechanical arms and reused. The ship continues into orbit, delivers its payload, and returns for its own landing. The entire system is designed to operate like a commercial airliner, refuel it, load it, and send it back up. But version 3 represents something fundamentally different from what came before. This isn't an upgrade, it's a complete redesign built from lessons learned through 5 flight tests that ranged from spectacular failures to history-making successes. Ship 39 is the first version 3 rocket, and according to SpaceX engineers, version 3 is basically a clean sheet design of the ship. We essentially took a bunch of lessons from version 1 and version 2, and we took a step back and said, what were the things that were really problematic either from a performance perspective or from a reliability perspective on the previous rockets, and then we directly address those with a variety of new designs. The goal isn't just to reach orbit, it's to stay there for 48 hours, rendezvous with other ships, and transfer propellant between vehicles in space. That last capability is the key that unlocks everything else. Because once you can refuel in orbit, you can go anywhere in the solar system with payloads that would be impossible to lift directly from Earth. The Raptor 3 engine. The engine sitting at the heart of this ambition is called Raptor 3, and it represents a level of engineering integration that most rocket companies wouldn't attempt because the risk of failure is too high. SpaceX has already built around 600 Raptor 2 engines, so they understand what works and what doesn't at a production scale that no other company has achieved. Raptor 3 takes that knowledge and simplifies it radically. Fewer parts, tighter integration, higher reliability. The effect is a lighter vehicle that's cheaper and faster to build while simultaneously being more powerful and more reusable than anything that came before it. The goal is to make rocket engines behave like jet engines on commercial airplanes, run them, inspect them, refuel them, and run them again without tearing them down for months of refurbishment between flights. Achieving full reusability at this scale is something people genuinely haven't done before, and the engineering challenges are immense. The first failure. Booster 18 was the first version 3 booster SpaceX built, and it was supposed to validate the entire design philosophy before they committed to mass production. The team was excited. This was their first chance to see if all the simulations and models translated into real-world performance. During a nitrogen system pressurization test, an explosion destroyed the rocket. Thankfully, SpaceX had designed the test to be safe. Even if something catastrophic happened, there were no propellants or reactive materials on the vehicle at the time. So the test site sustained minimal damage and nobody was injured. But losing the first version 3 booster before it ever fired its engines was a significant setback. The team regrouped around Booster 19, the second version 3 unit, and prepared for the next attempt. The 10-engine test. Attention all B-19 operators. This is the final go-no-go poll for today's operations. Our main objective today is a 10-engine static fire. Static fire is the culmination of the engineering process, bringing all the pieces of the puzzle together and lighting the engines. If you make it through that test successfully, you have pretty good confidence you're in a position to go fly. They lit all 10 engines successfully. They were ramping up to power and everything was looking good until a pad side abort was called. Some sensor tripped and commanded a fast shutdown at just 2.135 seconds into the burn. The shutdown was so abrupt that about half the engines sustained mechanical damage from the rapid deceleration of their internal components. It was a hard day, especially since they had to remove all 10 engines from the booster afterward for inspection. Thankfully, 10 of them were salvageable, which meant they could backfill engines from Booster 20 and keep making progress on Booster 19 without starting from scratch. The 33 engine attempt. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is the moment everything has been building toward. The first time SpaceX would attempt to fire all 33 Raptor 3 engines simultaneously on a version 3 booster. The countdown had proceeded through the go-no-go poll. Flight software, go. Avionics, go. Raptor, go. Stage, go. Every system checked green. The engines ignite. For a brief moment, everything works. 33 of the most powerful rocket engines ever built firing in perfect coordination, generating thrust that shakes the ground and floods the test site with sound and light. And then, just 1.8 seconds into the burn, they abort again. Sensors on one of the propellant manifolds reported pressure readings lower than expected, and the safety systems commanded an emergency shutdown. The team had made it through engine startup, but they couldn't sustain the full burn. The philosophy. Anytime that you walk into an operation where you want to turn on 33 of these enormously powerful engines and get them all to work together and walk away from it in one piece, that is a win. I think every test is always a success, and we had a bunch of findings on the ground systems, the vehicle and the engines that I think were really good to flag at this point. But definitely a bittersweet day. This is the SpaceX testing philosophy in action: rapid iteration, aggressive timelines, and the willingness to push hardware to failure in order to learn what the real limits are. It's expensive and it's risky, but it's also the only way they've found to move fast enough to make meaningful progress toward their goals. SpaceX has a saying, "Only the paranoid survive." The idea is that there's an enormous amount of information and data coming at you during these tests, and if you can use that data wisely, you can usually figure out where things are going to go wrong in the future. Almost every time something fails or goes wrong, there were clues in previous data and previous operations that could have predicted it, if you had known what to look for and been paranoid enough to catch it. Ship 36 and the long road back. While Booster 19 was going through its testing campaign, Ship 36 suffered its own catastrophic failure that took out not just the rocket but significant portions of the Massey's test site infrastructure. A cryogenic pressure vessel exploded during testing, and the blast damaged critical ground systems that took 10 months to rebuild. Losing a rocket is one thing. SpaceX has a production line and can build more. But losing the physical infrastructure of the launch pad or test site is genuinely difficult because you need months of repair work before you can get back to testing. Now, 10 months later, Massey's is back online with Ship 39 ready for its own static fire campaign. We run 60 seconds on Ship because you get to see how the vehicle thermals all shake out and just general vehicle performance. If you can make it through that, you're in a reasonable position to go fly. They light the engines, startup looks good, throttle up proceeds smoothly. And this time, the burn continues for the full duration without major anomalies. Ship 39 has passed its critical test. What this means? The journey of SpaceX is ultimately a journey to give humans access to the solar system and beyond, which is really the goal for Starship. The impact that this rocket is going to have on the world is something most people can't really comprehend yet. This is such a wild ride. The highs are high, the lows are low, as the team works toward ultimately launching people, which is going to be amazing. Version 3 isn't just another rocket. It's the foundational design that will put humans back on the moon and establish the first permanent city on Mars. Every explosion, every aborted test, every late night in the control room troubleshooting sensor data is part of building the transportation infrastructure for a multi-planetary civilization. It is not impossible just because it's far beyond what has been done before. We've proved that time and time again. SpaceX is attempting something that most people still consider impossible, making space travel as routine as air travel and doing it at a scale that can support thousands of people traveling to Mars. They're not breaking the laws of physics, they're just leveraging them more effectively than anyone thought possible. And every test, whether it succeeds spectacularly or fails dramatically, brings them one step closer to making the impossible inevitable. If you want to see how this story ends, subscribe now. Because when Starship finally lands humans on Mars, you'll want to say you watched it being built.